So here's another example. I know I've got to apply the chain rule here. How do I know I've got to apply the chain rule? If I look at the original function, y equals something, what do I do to get y? The first thing I do, knowing x, is to work out this bit in the bracket. I work out what 5x squared plus 2 is. And then I find out what 3 cos of that answer is. So there's 2 steps, 2 separate functions to apply, one inside the other. So the first function, the first thing I do is that, so that's what I call u. So I write u equals the inside bit, and then I rewrite the original function, replacing the inner bit with u. So I write down u equals, and then I rewrite the original function, y equals. So just write down what you think you'd get. So hopefully you get u equals 5x squared plus 2, the inner function, and I replace the u with 5x squared plus 2 with u to get y equals 3 cos u. Then I differentiate them. What's the differential of u with respect to x, and what's the differential of y with respect to u? Hopefully you can write down what those are. Again, just pause and write it down if you're looking at the video. Hopefully you get 10x for the first one. 2 down, take 1 off the power, and constants disappear. And this one, cosine becomes minus sine, so it will be minus 3 sine u. So we've just got to be careful of signs there. So that's our 2 differentiated. And now what does the chain rule tell us to do? It says that the differential is just the differential of with respect to u, in other words, ignoring what's inside the bracket, then multiply that by the differential of what's inside the bracket. In other words, you just multiply these 2 together. Yeah, it's been pointed out to me that, of course, when I differentiated this, I forgot to take the 1 off the power, which you're all screaming at me about. So, yeah, it should be just 10x. Thanks, Aaron. So, the differential of y with respect to x is y to u minus 3 sine u. Well, what is u? 5x squared plus 2. Multiplied by the differential of u, which is 10x. So can you see, using that wording, differentiate, ignoring, where's our original function? There it is. Differentiate, ignoring the inner function, ignore that. So what's the differential of 3 cos x minus 3 sin x? That's that bit. And then multiply it by the differential of what's inside the bracket, which is 10x. And then what I forgot to do on the previous example, because I left it like that so I could show this, is to then simplify. So for the previous example and this one, what I would now do is try and simplify. I can multiply the 10 by the minus 3 to get minus 30. And I put the x in front and then finish off with the sine 5x squared plus 2. So that would be my final. I'd leave it like that because this, of course, in the wave function is the amplitude. So the amplitude is actually x dependent as well as this. So we've got. Okay.